All of what we looked at in the first part of this video was all about finding antiderivatives and integrals, and the reason for this is to find areas. What we're going to be looking for is we're going to be looking for areas under a curve, in between curves, and areas of really strange shapes, and that's why this was developed. I chose a real simple function, which was f of x equals x squared plus 1. And what I want to do is I want to find the area, this purple area under here. And what Riemann and some of these other people did, and Isaac Newton and so forth, and they decided, well, what if these were all rectangles in here? And we made them really skinny, and we added up millions, no, billions, no, even more than that, trillions of these rectangles, and we added them all up. We would get really close to the real area because the amount of error outside of here would become so small. Well, what we would have is each one of these rectangles would have an area, which would be the length, which we'll call dx. It's a change in the x values. So it's from one x value to another, so we call it a dx. And it would have a length. It would go from 0 to the curve, which would just be this x squared minus 1. And what we want to do is we want to add all these up. And this is really a limit problem like from chapter 1. So many things go back to that limit problem, that limit chapter. But what we want to do is we want to add up all of the lengths times the widths. And we want to add them all up. And we want the area between 0 and 2, and we're going to put a new notation in here, 0 and 2. And this is the way we do this problem. We're going to do our antiderivative, and then we want to evaluate it for all of the area in between 0 and 2. So if I take the antiderivative, I'm going to get x to the third over 3 plus x. This time I don't need a plus c because I'm going to actually evaluate it for certain values of x. And this is the notation. We will put a straight line and a 2 to 0 or 0 to 2 here. Very simply, we put the 2 into our new function, our antiderivative that we just got. And we're going to get 2 to the third over 3 plus 2. And then we're going to subtract, putting the second one in, which is going to be 0 to 3 plus 0. This here becomes an 8 over 3 plus 2. Now 8 over 3 is going to be what? 2 and 2/3 plus 2 minus 0. So this thing is going to be 4 and 2/3. This is actually the area of this purple region that I covered with all these green rectangles. So this is the process. Follow this process carefully when you go to do your homework in section 4, which is 5 to 38 and 39 to 48 in section 4. If we did this one and we didn't want the area in between 0 and 2, but we want it between 1 and 2, if you think about it, the process would be the same. The antiderivative would be the same. But we're going to go between 1 and 2 rather than 0 and 2. And the reason is, if we did the integral between 0 and 1, we would get, say, this gold area in here. If we did the area between 0 and 2, we would get this green area in here. And if you think about it, the green area minus the gold area gives me the purple area, which is what I want. So I take the antiderivative and I put in the numbers like I did before, 2 to the third over 3 plus 2, right? And now I'm gonna, that's the whole purple area over here, or this green area that I covered with green, I don't know if you can see it, minus the gold area. Matter of fact, I'm gonna do this in gold, minus the gold area, which is 1 to the third over 3 plus 1. And that whole thing will give me the purple area that I wanted. So I'm going to get an 8 over 3 plus 2. It's going to come out to be 4 and 2/3 minus This is 1/3 plus 1, 1 1/3, and my final answer is going to be 3 1/3. The area of this purple region right here is going to be 3 1/3. The problem is that you're going to have is changing these functions into something that we can take a derivative of. And that's why you want to practice so much in section 5.1 before you move to section 5.4. These two are very important, and it's just these two sections that we're going to have a quiz on next Monday. So work hard, practice a lot, and you could ask me questions, and on Wednesday we'll have a chat. Be prepared to answer any questions during the chat time. All right, guys, stay healthy, stay strong. I'll talk to you soon. Bye-bye.